Okay, so we've learned about mixtures and we've learned about the particle model and other things. Yeah, there we go. So our next little unit is on separation techniques. As I said in the little unit on mixtures, we can have we can make compounds which are made from chemical reactions, and they're quite hard to get apart. But when we make mixtures, these things are often quite easy to get apart, or easier to pull apart. Don't quite require quite so much energy. We've got a number of really simple techniques for doing that. And of course, in this unit, we're going to test them all out and make use of them all. So sieving's something pretty easy. And we've done it for a long time. You can imagine people gathering wheat and trying to get the wheat from the chaff and creating for themselves some sort of sieving technique. We have some sieves in the science building, which is a bit like that one in the picture, but there's a whole series of them in a collection, and each sieve gets finer and finer, so you can put a whole lot of dirt in and separate out into small parts to make up the dirt. And that's something like geologists and geomorphologists like to do, because soil tells you a lot about what you can grow and things. So it's just simply relying on a pretty straightforward property of the matter, the size of the particles. You do that with your pasta and your rice. You get out of the water. Water goes through the sieve, that big stuff stays behind. We can get a bit fancier, and filtration is the same idea really, but in this case we've got a solution with some stuff suspended in it, which is really quite fine, that would go through a sieve, but it won't go through our filter paper. So the filter paper catches the suspended material or the sediment in our water. That's what we call the filtrate, and then the water falls through into the conical flask at the bottom there, and that's hopefully a cleaner residue. So we've cleaned the water a bit, we've got some of the dirt out of it, and the very fine dirt. So we've got the coarse dirt out if we sieve it, and fine sediments out if we put it through a filter paper. We can also use evaporation. So in this example here, we've got a mixture of salt and water in that little dish. We call it an evaporating dish, and it's over a Bunsen burner. Water boils at about 100 degrees Celsius. So obviously you want to get that nice and hot, and the water will boil off. But the salt stays behind, because salt's obviously solid. Salt doesn't become liquid until about 1465 degrees Celsius. So it's going to remain in a dish when the water's boiled off. Now, the only problem with that, of course, is you've got to keep the salt, which might be what you want, but you've lost the water. A desalination plant basically works this way. It collects the water though, which would mean it's using something more like distillation. So again, in this case, we're still using that boiling point, that property of different boiling of the two things. And if we've got salty water in this container here, in this case the salt will still remain, but the water boils and gets caught in this condensing tube. And these two tubes here, they're not really shown doing what they do best. You attach this end to the cold water tap and run cold water up this tube, and it chills the steam as it comes down, and the water comes out here into the sink. And in here, you get the clean water from inside there. So not, an efficient way of getting clean water. You probably wasted more clean water running it through the distillation tube here than you do when you get. But anyway, good way to get eucalyptus oil out of eucalypt leaves, or nice smelling things out of flowers. So the perfume industry uses lots of distillation of different flower types. Good way to make alcohol, rum, gin, whiskey, that sort of stuff. So it's using different boiling points. Paper chromatography is another really interesting idea, and chromatography has actually gone beyond paper chromatography. We use all sorts of types, and it's basically again reliant on the size of the particle. But now we're talking about particles moving through that filter paper, so even smaller particles. And we'll do a little prac with this during the term. So you've got a solvent down here. Water is often quite good, or you might use methylated spirits, depending on what you're breaking up. You put a sample of your ink or dye along the bottom here. The water rises up through the filter paper. As it does, it separates out the different colours that are used to make up that particular dye. So here you've got the origin. This might be your the dot you put down. And as the solvent has moved through the paper, a purple dot's appeared and a blue dot's appeared. So blue and purple have been used to make this red. We'll have a little bit of fun with that. So again, the smaller the particle, the further it rises. So the purple particle is bigger than the blue particle in this case. So it's a really clever way of separating things out. Floatation is another thing we use in all sorts of ways of moving things. We're going to separate using a separation funnel, but here you can see a flotation tank in a sewage plant, and we won't talk about what's on the sea on top, but it's a way of floating off all the heavier, the floaty stuff that's sitting on top of the water before you start filtering the water through other processes, and you can skim that off and remove all that material. So it's one way of removing things that will float on top of water. We're talking about milk as a colloid or an emulsion before, and the fact that milk from the cow has cream on top. Again, you put the milk in a flotation tank and remove the cream, and you make butter and things from the cream. Anyway, a little aside there. We can also use gravity, and this is a picture of a centrifuge. We'll have to get our old centrifuge out and have a bit of play with it. Well, not quite play, but we'll use it. And the centrifuge is often used in blood work, because blood that you take from your veins is full of all sorts of stuff. Red blood cells, white blood cells, blood plasma, heavier platelets, and they like to separate all that out so they can use the different blood products for different reasons in medicine. And the heavier the object is, the further it falls down the tube. Another example of this is when people go panning for gold. The gold being quite heavy will stay in the pan as you get rid of all the lighter dirt and things. So gravity is another way of causing things to fall apart. There's another property of the matter. The heavier the object, the more gravity is going to work on it, pulling it down towards the bottom. Some things are magnetic. So most metals, not all, but most metals are magnetic. So it's quite easy to get metals out of other substances by running a large magnet over them. And this is really common now in metal recycling, because you want the metal resource to use for something else. And so you can run these big magnets over and remove the metals from the plastics and glass and other things that might be mixed with in a reasonably quick way. And that's it.